Now I have got question 2, which is also very interesting, which is under spherical waves. Okay, yeah. So the question is, a person standing 1 meter from a portable speaker hears its sound at an intensity of 7.5 times 10 to the power negative 3 watts per square meter. Find the corresponding decibel level. Find the sound intensity at a distance of 35 meters, assuming that the sound propagates as a spherical wave. So what do we mean when we say spherical wave? In fact, let me just give you the basic idea behind spherical wave. So if you have got a spherical, okay. So now if you are standing here, this is a person, or maybe the source or the sound is coming from here. So from this point here all the way to that point, let's call it R1. That is the radius of the spherical. Then from that point all the way to the last point, we'll have R2. But it will keep on going just like that. And the wave will just be propagating. It will go. Now that is what we call the spherical wave. Now one thing we have to know is that whenever we are talking about intensity is given by the power divided by the area. Okay, because we are saying that intensity, the SI unit for intensity is watts per cube per square meter. Now this intensity, we have power divided by, so the area of the spherical wave is given by 4 pi r squared, like that, meaning that I can also replace the area with 4 pi r squared. So that's the basic idea behind intensity. So what we need to know is that intensity is given by power divided by area. But again, there is a formula which we have to be familiar with, the one for corresponding decibels. So the decibel is given by 10 log the intensity divided by intensity initial. Now this intensity initial is the hearing threshold, and this is constant. Okay, the I0 is always 1.00 times 10 to the power negative 12 watts per square meter. That is the hearing threshold. Okay, so you can only hear a sound which has got intensity of 1.0 times 10 to the power 12. So that's the basic idea behind spherical wave. Now, so if we have got two things, we have got if this is my spherical wave propagating in that manner, like I said, we are going to have from this point, this is the source. So from that point to there, I'll call it R1. Then from that point to that, I'll call it R2. So there is a ratio which we have to be familiar with. Okay, so let me call, I'm going to call this as intensity 1. Okay, I can even start with intensity 2. It's okay. Okay, let's start with intensity 1. So what we need to understand is that intensity 1 or intensity 2 divided by intensity 3 or intensity 1 should be equal to, and then even on top here I'll put power 1 divided by area 1. Okay, we're talking about 2 now, so I'll put 2 here. Even here I'll divide it by power 2 divided by area 2, but this power will not change. So initially I'll just say intensity 2 divided by intensity 1 is equal to, the power is the same. Okay, then I divide this by area 2 divided by power divided by area 1, like that. So this is the same as if I can put power divided by area 2, then I put divided by power divided by area 1. At the same time, it is power divided by area 2 times area 1 divided by power. So the power and power can go, so I'll only remain with area 1 divided by area 2. So what I'll have now is this ratio. I'm going to have intensity 2 divided by intensity 1 will be equal to area 1 on top divided by area 2. Because of this one is down, or this one is down here, this one is on top. So what is area? So under spherical wave, area is given by 4 pi. Area is given by 4 pi r squared. So I'll have to specify this. I'm going to say my area 1 will be 4 pi r1 squared divided by area 2 will be 4 pi r2 squared. Now I can clearly see that these two can cancel out. So I'll have area 2 divided by area 1 to be equal to area 1 squared divided by area 2 squared. This formula is very important, this ratio. In some books, you will see this formula to be written as area 1 divided by area 2, or intensity 1 divided by intensity 2 is equal to area 1, okay, area 2, or radius 2 squared divided by the radius 1 squared, like this. So this and that, they are the same. So you choose which one to use. Now, we'll be using this relationship for this question, and also the formula for the corresponding decibels for us to work out the first question. So the first question is saying find the corresponding decibels. Now, like I said, the formula which you need to know for decibel is 10 log open brackets the intensity divided by intensity initial. So intensity initial is always 1.0 times 10 to the power negative 12 watts per square meter. So this is the threshold hearing. Now I can plug in the values. This intensity which is on top here I have, which is 7.5. So this will be given by 10 log, then this one is 7.50 times 10 to the power negative 3. I divide this by 1.0 times 10 to the power negative 12, like that. So if I get my calculator, I'll say 10 log, click on log, then open the brackets, 7.50 exponent negative 3 divided by 1.00 exponent negative 12. Then I close the brackets. So the answer I'm getting is 98.75. So the SI unit for corresponding decibels is small b, d, then capital B. So this is the answer for the first part. Now the second question is saying find the sound intensity at a distance of 35 meters assuming that the sound propagates as a spherical wave. So if the sound propagates as spherical wave, we always use this ratio. So I'll have r1 squared divided by r2 squared, like that. Now the r is the distance in this case. So the first distance, which is r1, is this one. The second one is that one. So we want to find I2. Okay. So now if I plug in the values here, I2 I don't know. I1 is 7.0 times 10 to the power negative 3. Then R1 is 1.0. Now I square it. R2, this is supposed to be R2. So R2 is 35. Now I square it. Okay, so we cross multiply. We'll find that we'll have 35 squared is 1222. So 1225, not 22, times I2 will be equal to 7.50 times 10 to the power negative 3, like that. Now we can divide both sides. We divide both sides by 12.5. Even here 12.5. So my I2 will be equal to, so 7.50 exponent negative 3 or times 10 to the power negative 3 divided by 12.5. Okay, so 7.50 times 10 to the power negative 3 divided by 1225. So I'll put my answer in scientific notation. So that should be 6.12 times 10 raised to the power negative 6. Since I don't have space this side, allow me to put this answer here. So the intensity 2 will be equal to 6.12 times 10 to the power negative 6 watts per square meter, like that. So that's my answer for the first part. Then the third question, which is part C, is saying find the decibel at this point. Now they want us to use the same formula: 10 log I divided by I0. I0 is always constant, is 1.0 times 10 to the power 12. Now this, the top part, I'll use this intensity because at the distance of 35 the intensity is this. So I'll have 10 log open brackets, the I is 6.12 times 10 raised to the power 6. The I initial is always this. Now what is our corresponding decibels? So 10 log open brackets 6.12 times 10 to the power negative 6 divided by 1.00 times 10 to the power negative 12. Then I close the brackets. So the answer I'm getting is 7. Oh, okay. What answer am I getting now? Okay, let me redo it. I'm saying 10 log open brackets 6.12 times 10 to the power negative 6 divided by 1.0 times 10 to the power negative 12. 1.0 times 10 raised to the power 12. Then I close the brackets. Okay. So what answer am I getting? I'm getting 67.86 decibels. So 67.867, which is the same as 8 of 87 if I round it off, decibels. So this is my answer for the second part. Now this is making sense. When we had the intensity of this, the corresponding decibel was 98. Okay, now this has reduced to 6.12 times 10 to the power negative 6. We expect the corresponding decibel to reduce as well. That's why it is 66. 66 is less than 98, which is making sense. So initially the basic idea which I've given you here is you can solve any question for spherical wave. Just know that ratio is very important. Know that the spherical wave is given by power divided by area. Then area of the spherical wave is given by 4 pi r squared. Okay, then the ratio again, that I2 divided by I1 is given by r1 squared r2 squared, like that. Then you can reshuffle them. That is just okay. Okay, so that is it for this question, which involves spherical wave and corresponding decibels. Okay.